Happy learning! Today we're going to talk about the inverse of a square matrix, in particular matrix equations. All right, so what exactly is the inverse of a square matrix? Well, two matrices A and B are called inverses of each other if A times B is the identity matrix and B times A is the identity matrix. So you could think of this like with numbers, it'd be like 2 and 1/2 are inverses of each other because they multiply together to give you 1. So it's the same idea but with matrices. Okay, so we write A equals B inverse and B equals A inverse if the matrices are inverses of each other. So this this exponent of -1, that just means inverse. Okay, so just for example, if A is the matrix 1, 1, 2, 1, and B is the matrix -1, 2, 1, -1, we could check if these two matrices are inverses by just multiplying them together and see if we get the identity matrix. All right, AB. If we do this matrix multiplication, we go across the row, down the column. -1 plus 2 is 1. 2 minus 2 is 0. -1 plus 1 is 0. 2 minus 1 is 1. All right, so AB gives us the identity matrix. Now let's check if BA also gives us the identity matrix. -1 plus 2 is 1. -2 plus 2 is 0. 1 minus 1 is 0. 2 minus 1 is 1. Okay, so these matrices are inverses of each other. But how do you find the inverse of a matrix? That's what we're going to talk about today. So we're going to need something called elementary row operations. All right, elementary row operations are going to be used to find the inverse of a matrix. There's 3 of them, and these are just some operations we're allowed to do on the matrix. The first is interchange 2 rows. The next operation is we could add a multiple of 1 row to another row. And then the third and final elementary row operation is we can multiply a row by a non-zero constant. All right, and so how we're going to find the inverse of a matrix is pretty simple. Well, it's easy to describe. The steps are a little bit tricky, but we'll get it. All right, so to find the inverse, so the first step is we're going to form what's known as an augmented matrix. We're going to have our matrix on the left, then we're going to have a vertical line, and we're going to have the identity matrix on the right. All right? Then we're going to perform row operations. So we're going to perform some row operations, and what remains will be the identity matrix on the left and some new matrix B on the right. And if we do it correctly, B will be the inverse of A. So whatever matrix ends up on the right will be the inverse of the matrix we're interested in. All right, so let's do an example. We're going to use A here. Ideally, we'll find its inverse, which is this. All right, so let's find the inverse of the matrix 1, 1, 2, 1. All right, so we're going to start by making an augmented matrix. We're going to have our matrix on the left, the identity matrix on the right. And now we want to perform row operations. So we get the identity matrix on the left, and then whatever's left over on the right. So we need a 1 in the top row, zeros below it, and then in the second column, we need a 1 and zeros above it. All right, so let's use this 1 in the top row to eliminate all the 1s below it. So the way we're going to do that is we're going to add -1 copies of row 1 to row 2. So row 2 will become row 2 minus row 1. So our top row stays the same, and our bottom row now becomes our second row minus the first row. 1 minus 1 is 0. 1 minus 2 is -1. 0 minus 1 is -1. And 1 minus 0 is 1. All right, so I'm happy with this 1 here. Our goal is to have, actually I'm happy with the entire first column. Our goal is to get the identity on the left. Let's now multiply the second row by -1. So row 2 becomes negative row 2. And why are we doing that? Because I want a 1 in this entry. So we have top row doesn't change. Bottom row becomes this. And now we're going to use this 1 in the second column to turn this 2 into a 0. And so how do we do that? Row 1 will become row 1 minus 2, row 2. Right? If we subtract off 2 copies of this second row from the first row, this will turn into a 0. All right, so let's do that. Second row stays the same. And what do we get for the top row? 1 minus 2 times 0. That's 1. 2 minus 2 times 1. 1 minus 2 times 1. 0 minus 2 times negative 1. We have the identity matrix on the left. So this here, this is A inverse. All right, so A inverse is the matrix negative 1, 1, 2, negative 1. And this works not just for 2 by 2 matrices, but it works for 3 by 3 matrices as well. So let's do another example, but this time with a 3 by 3 matrix. All right, so A is this 3 by 3 matrix. We want to find A inverse. So try this on your own. Try to follow the same steps that we just did with the 2 by 2, but there's just going to be a few more because we have a 3 by 3. But I do understand that this is a little bit tricky at first, so if you can't get it, it's not the end of the world. All right, so how do we start? We start by taking our matrix and putting the identity matrix to the right of it. We want to get a 1. Once we're done, we need a 1 in this top left corner. So we could either divide this row by 2, or we could swap rows. So I'm going to swap rows 1 and 2. All right, doing that will get us a 1 in the top row. Okay. Now I want to use the 1 in the top row to eliminate everything below it. All right, so row 2 will become row 2 minus 2 row 1. Right? If we take row 2 and subtract off 2 copies of row 1, this 2 is going to turn to a 0. And then similarly, row 3 will become row 3 minus row 1. This 1 will turn to a 0 after we perform that operation. All right, so row 1 stays the same. The second row, 2 minus 2 is 0. Five minus 8 is negative 3. 4 minus 6 is negative 2. 1 minus 0 is 1. 0 minus 2 is minus 2. And 0 minus 0 is 0. So that's our new second row. Third row is going to be a little bit easier. We just take the third row and subtract the first row. So 1 minus 1 is 0. Negative 3 minus 4 is negative 7. Negative 2 minus 3 is negative 5. 0 minus 0 is 0. 0 minus 1 is minus 1. And 1 minus 0 is 1. So now we're here. We need a 1 in this middle square, middle location. So what I'm going to do is I'm going to multiply the second row by negative 1/3. All right, so our first row stays the same. Our second row becomes 0, 1, 2/3, minus 1/3, 2/3, and 0. And our bottom row we didn't touch. Okay, and so what I want to do now is I want to use this 1 to eliminate this -7. All right, so how we're going to do that is row 3 will become row 3 plus 7, row 2. All right, and so we could just do this with a calculator if you struggle with the fractions. All right, so it's -5 plus 14/3. So that's -1/3. 0 minus 7/3 is -7/3. -1 plus 14/3 is 11/3. And then 1 plus 0 is 1. Okay, so we're starting to get our identity matrix over here on the left. Let's now turn this into a 1. And the way we could do that is row 3 becomes -3, row 3. So we're scaling it by a factor of -3. Okay, and so we got the bottom half of our identity matrix. Now we need the top half. So we're going to use this 1 to eliminate everything above it, and then we're going to use this 1 to eliminate everything above it. All right, so our next step, we could do row 2. Row 2 becomes row 2 minus 2/3 row 3. And row 1 becomes row 1 minus 3 row 3. So this first line will eliminate this 2/3. The next one will eliminate the 3. All right, so let's take a look. Looking at row 2, I guess. -1/3 minus 14/3. That's -15/3. That's -5. Well, all right. Yeah, -5. 2/3 minus negative. So 2/3 plus 22/3. It's 24/3, 8. Okay, and 0 minus a minus. So 0 plus 2 times 2/3 of 3, which is 2. So this is a 2. Okay, and now to get our top row, it's row 1 minus 3 copies of row 3. So 0 minus 21 is minus 21. 1 minus -33 is 34. And 0 plus 9 is 9. All right, we have one last step. We need to get rid of this 4. So row 1 becomes row 1 minus 4, row 2. All right, so the left-hand side will be our identity matrix. The bottom 2 rows stay the same. And what happens to the top row? Well, we're taking row 1 minus 4 copies of row 2. Negative 21 plus 20, that's negative 1. 34 minus 32, that's 2. And 9 minus 8 is 1. This here on the right is the inverse of the matrix we started with. So this is A inverse. I know it's a little bit of a pain, but like your graphing calculator will have built-in functions to do this. So this is the step that your calculator is doing behind the scenes. Okay, so if we have a 2 by 2 matrix, then the inverse is 1 over AD minus BC, so this diagonal minus this diagonal, times the matrix D minus B minus C A. This is provided that we don't divide by 0. Okay, if this term is 0, then there's no inverse. All right, so let's look at an example. So find the inverse of the matrix 3, 2, 7, 5. All right, and so AD minus BC, that's 3 times 5, 15 minus 7 times 2, 14. 15 minus 14 is not 0, so we do have an inverse. And so A inverse is equal to 1 over 3 times 5 minus 7 times 2. Our new top left is our old bottom right, 5. Our new top right is negative of our original one, negative 7, negative 2, and then 3. All right, what is this value? This is just 1. So A inverse is this. All right, so if we have a 2 by 2 matrix, it's very easy to find the inverse. You could just use this theorem here. And so why do we care about matrices? We could use matrices to represent systems of equations. Okay, so matrices can be used to represent systems of equations. Okay, so for example, if we had the system of equations 2x plus 5y plus 4z equals 4, x plus 4y plus 3z equals 1, and x minus 3y minus 2z equals 5, we could write this as what's known as a matrix equation. We could take all of the coefficients on the left-hand sides, turn that into a matrix. Right, so the coefficients of x are 2, 1, and 1. The coefficients of y are 5, 4, and negative 3. And the coefficients of z are 4, 3, and negative 2. And if we multiply this by the matrix x, y, z, and set it equal to the right-hand side. Right, if we were to do this matrix multiplication, it'd be 2x plus 5y plus 4z. 2x plus 5y plus 4z equals 4. This represents each of the equations. And one way to solve this system of equations is to multiply both sides of the equation by the inverse of this matrix. We know what the inverse of this matrix is. We found that. That was that long example we just did. This is the inverse of that matrix. So to solve this system of equations, we multiply both sides of this equation by A inverse. All right, so A inverse is minus 1, minus 5, 7, 2, 8, minus 11, 1, 2, minus 3. So I multiplied the left-hand and right-hand side of this equation by A inverse. This is A inverse times A. That's just the identity matrix. And remember, multiplying by the identity matrix doesn't do anything. It's like multiplying by 1. So the left-hand side of our equation is just x, y, z. And then the right-hand side of the equation is whatever we get by doing this matrix multiplication. Negative 4 plus 2 plus 5. That's 3. Negative 20 plus 8 plus 10. That's minus 2. And 28 minus 11 minus 15. That's positive 2. So we were able to quickly solve this systems of equations, provided that we knew the inverse matrix. So if you find the inverse matrix, you could use that to solve systems of equations. Okay, I know this was a little bit tough today, but I hope you bared with me. And yeah, let me know in the comments if you have any questions, and I'll see you next time. Bye-bye.